Hello, and welcome to G Fun Facts Online. What if I told you that controlling your computer with your mind isn't science fiction anymore? What if the key to unlocking this power wasn't some mysterious psychic ability, but something we see every day? Light. Specifically, lasers. Today, we're diving into the mind-blowing field of neurophotonics, where scientists are using lasers to build a direct bridge between the human brain and computers. This is the science of brain-computer interfaces, or BCIs, and it's poised to change everything we thought we knew about medicine, communication, and the very nature of thought itself. So how exactly do you use a laser to talk to a brain? It breaks down into two main strategies: reading information from the brain and writing information to it. Let's start with reading. One of the most promising non-invasive methods is called functional near-infrared spectroscopy, or fNIRS. It sounds complicated, but the principle is simple. When a part of your brain is active, it needs more oxygen. This means more oxygen-rich blood flows to that area. By shining near-infrared laser light onto the scalp, scientists can measure how that light is absorbed, which tells them precisely where the blood is flowing. It's like seeing a real-time heat map of your thoughts. For an even more detailed picture, researchers use something called two-photon microscopy. This lets them look deep inside a living brain and watch individual neurons light up as they fire. Imagine seeing a single brain cell responsible for a memory flicker into existence. This technique is giving us incredibly detailed, real-time movies of neural circuits in action, helping us understand the very mechanics of how our brain works. But what about the other direction? Can we use light to control the brain? The answer is a resounding yes, thanks to a revolutionary technique called optogenetics. This is where things get truly wild. Scientists can genetically modify specific neurons to express special proteins originally found in algae that act like tiny, light-activated switches. When you shine a laser of a specific color onto these modified neurons, you can turn them on or off with millisecond precision. Think about that. It's a level of control that's simply impossible with any other method. Scientists have already used optogenetics in animal models to do incredible things, like pinpointing the exact brain circuits responsible for addiction, and even artificially creating memories in mice. So what's the point of all this? The applications are staggering. For people with paralysis or ALS, laser-based BCIs could mean controlling a prosthetic limb with natural intuition, or communicating by simply thinking of the words. It could lead to new treatments for Parkinson's or epilepsy by allowing doctors to precisely target and correct faulty neural circuits. And beyond medicine, imagine playing a video game or controlling a drone with the power of your thoughts. Researchers are already developing systems that let people interact with AI models like ChatGPT using only their brain activity. Now, before you start expecting to download Kung Fu skills directly into your brain next week, we have to acknowledge the challenges. Invasive techniques like optogenetics require genetic modification and implanting fiber optics, which raises huge safety and ethical questions. And for non-invasive methods, the skull is a pretty good barrier, scattering light and limiting how deep we can see. But researchers are making incredible progress. New laser technologies are allowing us to see deeper and more clearly than ever before. AI and machine learning are getting better at decoding the complex language of the brain. The science of engineering lasers for brain-computer interfaces is doing more than just creating new gadgets. It's opening a new window into the mind. It's a journey that promises to transform our world in ways we are only just beginning to imagine. Thanks for tuning in to G Fun Facts Online.